Implicit differentiation. Find dy dx if x power 3 minus 5xy plus y power 3 equals 4x. Here we have x and y on the same side, and we have y power 3. Here we have x square y plus y square x equals 25. Of course, we know how to find a derivative for a function like this. Y equals x square or x power 3 minus 4x. It is equal y dash equals 3x square minus 4. But here we have y related with the variable x with a relation containing x and y itself. So how we find dy dx? By differentiate both sides with respect to x, we get the derivative of x power 3 is 3x square minus 5. Here we have two functions, the product of two functions, x multiply y, and the derivative of x multiply y is the first multiply the derivative of the second. The derivative of y with respect to x is dy dx plus the second function itself, it is y multiply the derivative of the first. The derivative of the first is 1. The derivative of x with respect to x is 1 plus derivative of y power 3 with respect to x is 3y square. And don't stop here like this, because the derivative is with respect to x, so we have to multiply by dy dx equals the derivative of 4x is 4. What is the new here? When we make the derivative of x power 3, it's 3x square, and we stop here. But when you make a differentiation to y with respect to x, we must write dy dx. We make a differentiation with another variable. Now don't forget that the required is to find dy dx. So we simplify the left hand side, 3x square minus 5x multiply dy dx minus 5 multiply y equals minus 5y plus 3y square dy dx. It is equal 4. Collecting dy dx in the same side, we write 3x square minus 5y square minus 5y minus 4 equals 5x dy dx minus 3y square dy dx. Here is 3 dy dx. So 3x square minus 5y minus 4 equals, we're taking dy dx as a common factor, dy dx multiply 5x minus 3y square. So dy dx equals 3x square minus 5y minus 4 over 5x minus 3y square. And this is the final result. dy dx equals 3y square minus 5y minus 4 over 5x minus 3y square. And now we solve b. How to find the dy dx? Don't forget that we have x square y. It is the product of two functions and the differentiation with respect to x. So by differentiate both sides with respect to x, what we get? First, we have, as I told you, the product of two functions. So we have the first function, x square, multiply the derivative of the second. It is dy dx. We make the differentiation with respect to x. So when you make a differentiation of y, it will be dy dx plus the second function multiply the derivative of the first. The derivative of x squared is 2x plus, here also we have the product of two functions, y squared multiply x. So we have the first, it is y squared multiply the derivative of the second, which equal 1, plus the second multiply the derivative of the first function. The derivative of y squared is 2y dot dy dx, dy dx, and don't forget that, which equal the derivative of 25 is 0. So we have dy dx x square plus 2xy plus y square plus 2xy dot dy dx equals 0. By taking dy dx as a common factor here, we can write dy dx multiply x square plus 2xy equals negative negative 2xy minus y square. So the final result is dy dx equals negative 2xy minus y square over x square plus 2xy.